In this lecture, we are discussing the problems related to probability. First question is, suppose that x is a continuous random variable. Its probability density function is given by f of x is equal to c into 4x minus 2x square when x is between 0 and 2 and 0 otherwise. What will be the value of c and what is find p of x greater than 1. We can use the property integral minus infinity to plus infinity f of x dx is equal to 1. Here the limit is such that x ranges from 0 to 2. Therefore, update the limits. Integral 0 to 2 f of x dx equal to 1. And substituting the value of the function f of x, that is integral 0 to 2, when x ranges from 0 to 2, the value of f of x is given by c into 4x minus 2x square. Substitute the function. C being constant, take it outside. C into integral 0 to 2 4x minus 2x square dx. This is equal to c into integral 0 to 2 4x dx. That is 4 into x square by 2 within the limits 0 to 2. Minus integral 0 to 2 2x square dx. 2 into x cube by 3 within the limits 0 to 2. That is equal to c into 2 square minus 0, that is 4 minus 0 minus 2 by 3 into 2 cube minus 0. 2 cube is 8 minus 0 equal to 1. That is c into 4 minus 0 into 2, 8 minus 8 into 60 by 3 equal to 1. And cross multiplying c into 24 minus 60 by 3 equal to 1, which is equal to 8c by 3 equal to 1. Therefore, c is equal to 3 by 8. That's the value of c. Next, we have to find p of x greater than 1. P of x greater than 1. Substitute in our standard property, that is integral minus infinity to plus infinity f of x dx equal to 1. Here the range is from 1 to infinity. Since x is greater than 1, therefore we update the limits as integral 1 to infinity f of x dx equal to integral 1 to infinity f of x dx. Substituting the value of f of x when x is greater than 0 and x is less than 2. Function will be c into 4x minus 2x square. Substituting that, c into 4x minus 2x square dx within the limits 1 to infinity. And here the maximum limit is 2. Therefore, we can again update it as integral 1 to 2 c into 4x minus 2x square dx. Taking the integral, c being constant, we can take it outside. And integral 1 to 2 4x minus 2x square dx. is equal to c into integral 4x is 4 into x square by 2, which is limits 1 to 2, minus 2 into integral x square dx, that is x cube by 3, which is the limits 0, 1 to 2, that is equal to 2 into 2 square minus 1, that is 4 minus 1 is 3, minus 2 by 3 into 2 cube minus 1, that is 8 minus 1. Therefore, c into 6 minus 8 minus 1 is 7 into 2 14. 6 minus 14 by 3 into c. Substitute the value of c, which is 3 by 8. Taking cross multiplication, we get 18 minus 40 by 3. That is 3 by 8 into 4 by 3. That is equal to 1 by 2. That is the probability of x greater than 1 is equal to 1 by 2. Next question is, a continuous random variable x has the probability density function given by f of x is equal to 3x square. And x is in between 0 and 1. Find k such that p of x greater than k is equal to 0.5. Here the probability is already given. We have to find the value of k, for which the probability of x greater than k is equal to 0.5. We can start with the standard property, integral minus infinity to plus infinity f of x dx is equal to 1. And x is between the limits 0 and 1. Therefore, we can apply the limits as integral 0 to 1 f of x dx, which is equal to integral 0 to 1. Substitute the value of f of x, that is 3x square dx. I'm taking the integral 3 into x cube by 3, which is the limit 0 to 1. That is equal to 1 cube minus 0. That is 1 minus 0 equal to 1. It is given that p of x greater than k is equal to 0.5. Therefore, since x is greater than k, we can take the limits as integral k to infinity. Since x is greater than k, we can apply the limits as integral k to infinity f of x dx. Which is the probability, and it is given as 0.5. Therefore, substituting the value of the function f of x and taking the integral k to infinity f of x is equal to 3x square dx. That is 3 into x cube by 3, which is the limits k to infinity. And is equal to 0.5. And the x ranges from 0 to 1. Therefore, we can take the limits as k to 1. And substituting 1 cube minus k cube. 1 cube is 1. And 1 minus k cube equal to 0.5. And k cube is equal to 1 minus 0.5. That is equal to 0.5. And the value of k is equal to cube root of 0.5. That is equal to 0.7938. Therefore, the value of k is equal to 0.7938. Next question is, let x be a continuous random variable with the probability density function f of x given as. When x, the value of x ranges between 0 and 1, the function value will be 2x and 0 for otherwise. We have to find the p of x less than or equal to 0.4, p of x greater than 3 by 4, p of x greater than 1 by 2, p of x in between 1 by 2 and 3 by 4, p of x greater than 3 by 4 divided by p of x greater than 1 by 2, and also p of x less than 3 by 4 divided by p of x less than 1 by 2. First, we have to find p of x less than or equal to 0.4. So, take the limits as such. In our standard equation, standard property, integral minus infinity to plus infinity f of x dx. We can update the limits as, since x is less than or equal to 0.4, we can update the limits as integral minus infinity to 0.4, and x ranges between 0 and 1. Therefore, the starting limit is 0, 0 to 0.4. Finally, the limits of the integral has changed to integral 0 to 0.4 f of x dx. Substitute the function. F of x is 2x for all values of x less than 1. Therefore, integral 0 to 0.4 2x dx. Take the integral and put the limits. 2 into x square by 2 within the limits 0 to 0.4. 0.4 square minus 0. And that is equal to 0.16. That is the probability when x is less than or equal to 0.4. Second part is p of x greater than 3 by 4. Since x is greater than 3 by 4, the limits can be changed to 3 by 4 to 1 as x varies between 0 and 1. Integral 3 by 4 to 1 f of x dx. And when x is greater than 3 by 4 and less than 1, the function will be take the value 2x. Therefore, integral 3 by 4 to 1 2x dx. Take the integral and put the limits integral, and then it will be 2 into x square by 2 within the limits 3 by 4 to 1. That is 1 square minus 3 by 4 square. That is 1 minus 0.56. That is equal to 1 minus 9 by 4. That is minus 5 by 4. Sorry, it's not 9 by 4. 1 minus 9 by 60. Which is equal to 1 minus 0.5625, and that is equal to 0.4375. That is the probability when x has got value greater than 3 by 4. Next, we have to find p of x less than p of x greater than 1 by 2. So, take the limits as x greater than 1 by 2. Therefore, integral 1 by 2 to 1, as 1 is the maximum limit, f of x dx. Integral 1 by 2 to 1 f of x dx. For all values of x less than 1, the function is 2x. Therefore, integral 1 by 2 to 1 2x dx. Taking the integral and putting the limits, integral, then it will be 2 into x square by 2 within the limits 1 by 2 to 1. That's 1 square minus 1 by 2 square. Just 1 minus 1 by 4. That is equal to 3 by 4. Fourth part is finding the probability of x between 1 by 2 and 3 by 4. Then p of x greater than 1 by 2 and x less than 3 by 4. Therefore, the limits will be from 1 by 2 to 3 by 4. F of x dx. And the function for between when the x values ranges between 0 and 1 is 2x. therefore it becomes integral 1 by 2 to 3 by 4 2x dx. Taking the integral and putting the limits, 2 into x square by 2, then the limits 1 by 2 to 3 by 4. 3 by 4 the whole square minus 1 by 2 the whole square. Nine by 60 minus 1 by 4, and which is equal to 5 by 60. Next part is P of x greater than 3 by 4 divided by x greater than 1 by 2, which is equivalent to P of x greater than 3 by 4 divided by P of x greater than 1 by 2. We have already found that probabilities P of x greater than 3 by 4 and P of x greater than 1 by 2. P of x greater than 3 by 4 has got the value 0.4375. P of x greater than 1 by 2 has got the value 3 by 4, which is 0.75. It is equal to 7 by 12. Next is P of x less than 3 by 4 divided by x greater than 1 by 2. Equal to P of x less than 3 by 4 divided by P of x greater than 1 by 2. P of x less than 3 by 4 means integral 0 to 3 by 4 f of x dx. And for all values of x between 0 and 1, function will be 2x. Divided by integral 0 to 1 by 2. Now x is greater than 1 by 2. Therefore, the limits will be from integral 1 by 2 to 1. Since x is between 0 and 1, integral 1 by 2 to 1, 2x dx. Taking the integral and putting the limits, 2 into x square by 2 to the limit 0 to 3 by 4. 2 into x square by 2 within the limits 1 by 2 to 1. That is 3 by 4 the whole square minus 0 and 1 square minus 1 by 2 the whole square. That is 9 by 16 minus 1 by 1 minus 1 by 4. That is equal to 9 by 16 divided by 3 by 4. Multiplying 9 by 16 into 4 by 3. Which is equal to 3 by 4. That is the probability of x less than 3 by 4 divided by probability of x greater than 1 by 2. Dividing the both the probabilities, we get the value 3 by 4. Thank you.